Right. Last class we discussed about continuity equation, three-dimensional continuity equation. Right now we are going to solve the problems related to continuity equation. Now in this problem, the diameter of the pipe at a section 1,1 and section 2,2, the diameter of the pipe at section 1,1 and 2,2 are 10 centimeter and 15 centimeters respectively. Find the discharge through the pipe. If the velocity of water flowing through the pipe at section 1 is given, that is 5 meters per second, determine the velocity at section 2,2. Right, suppose this is one pipeline, this is section 1,1, this is section 2,2, right? The diameter of the pipe at section 1,1 and section 2,2, section 1,1 10 centimeters, dia equal to 10 centimeters, this is say D1, and section 2,2, D2 is equal to 15 centimeters. Find the discharge. Right, what is discharge? And also what data they have given through the pipe. If the velocity of water flowing through the pipe at section 1 is, velocity at section 1 is given, that is 5 meter per second. And also determine the velocity at section 2,2 and what is V2. Right. In this problem, they have given two sections, section 1,1 and section 2,2. Section 1,1 diameter given 10 centimeters. Section 1,1 velocity of flow given, that is 5 meter per second, and section 2,2 diameter only given. We are going to determine the velocity at section 2,2, that is say V2. And also discharge also we are going to determine. Right. Based on this given data, first we are going to determine the discharge flowing through the pipe. Discharge flowing through the pipe. What is the formula? As per continuity equation or discharge formula, Q is equal to A1 V1 equal to A2 V2. This is the standard formula. Q equal to A1 V1 is equal to A2 V2. First we are going to determine the discharge Q. So that we are going to take Q is equal to A1 V1. Right, what is A1? Right, A1 is equal to, at section 1,1, the diameter of the pipe given, that is 10 centimeters. So that cross-sectional area is equal to pi d square by 4, that is equal to pi into d is equal to 10 centimeter. First this convert into meters. This is equal to, d is equal to 0.1 meter. 10 centimeters converts into meters, that is equal to 0.1 square divided by 4. Then area is equal to 0.00785 meter square. Right. Then A1 is calculated here, velocity of the flow given, therefore Q is equal to discharge through the pipe. Q is equal to, A1 is equal to 0.00785 into velocity of flow through the pipe at section 1,1 is given, that is 5 meter per second. Finally we have the discharge. Discharge Q is equal to 0.03927 meter cube per second. Right. In this problem they have given two sections, section 1,1 diameter given, section 1,1 velocity given, section 2,2 only diameter given, velocity is unknown. First they asked here, what is discharge? Discharge Q is equal to, our continuity equation is equal to, Q is equal to A1 V1 is equal to A2 V2. For the determination of discharge Q, we are going to take at section 1,1. At section 1,1 diameter known to us, velocity is also known to us. Based on the diameter, we are going to determine the area. Once we know the area and velocity, finally we determine the discharge flowing through the pipe. Then second question is, right, second one, what is the velocity of flow at section 2,2? Velocity of flow at section 2,2, velocity of flow at section 2,2 is equal to what value? Right, here also same diagram. This is section 1,1, section 1,1, section 2,2, area given, diameter given, diameter is equal to d1 is equal to same 10 centimeters, v1 is equal to 5 meters per second, d2 is equal to 15 centimeters. This converts into meters, 0.15 meters. Then v2 is equal to what is the value? Right, for the determination of velocity at section 2-2, apply continuity equation. A1 v1 is equal to a2 v2. A1 already we have determined, velocity given at this section, right? Then A2 is equal to what is the formula? A2 is equal to same formula, pi d square by 4, pi into what is the diameter? 0.15 meters, 0.15 square divided by 4. Therefore A2 is equal to 0.01767 meters square. A2 is known to us. In this equation, A1 is already we have determined, velocity at section 1 is given, A2 is determined here, only unknown is V2. Therefore V2, velocity at section 2-2 is equal to, or velocity at section 2 is equal to A1 V1 divided by A2. A1 already determined, that is 0.00785 4 A1 into velocity 5 meter per second divided by A2. A2 is this value, 0.01767. Therefore velocity at section 2-2 is equal to 2.22 meters per second. Right. So here we have used only continuity equation. Q is equal to A1 V1 is equal to A2 V2, or the continuity equation states that the velocity into area at one section must be equal to velocity into area at the another section. Based on this formula, we have determined the discharge and also velocity V2 at section 2-2. Right. Now we are going to solve one problem. This is also related to continuity equation. First you read the problem, what data they have given. Based on the given data, what formulas we are going to use, what methodology we are going to use, then we are going to solve the problem. What data they have given, what data they have asked, that we are going to estimate here. Right, in this problem, a 30 centimeter dia pipe convey water. That means suppose this is 30 centimeter dia pipe, there D is equal to 30 centimeter dia pipe convey water, branches into two pipes, that divides into two pipes, so like this. Okay, pipes divides into two diameters 20 centimeters and 15 centimeters. This is equal to 20 centimeters, say this is D1, and another one is say D2 is equal to 15 centimeters. Right. Then respectively, if the average velocity in the 30 centimeters dia pipe is 2.5 meter per second, velocity in the 30 centimeter dia pipe is given, that is 2.5 meters per second. Then find the discharge in the pipe. What is Q? Also determine the velocity in 15 centimeters pipe. That means what is the V2? This is the 15 centimeters pipe, this is 20 centimeters pipe. If the average velocity in 20 centimeter dia pipe is, that means the velocity in 20 centimeter dia pipe is given, that is equal to 2 meters per second. Right, this is the given problem. Here 30 centimeters dia pipe convey water that branches into two ways. One is 20 centimeter dia pipe, another one is the 15 centimeter dia pipe. The velocity in case of 20 centimeters dia pipe given, that is equal to 2 meter per second, and the velocity in the main pipe is also given, that is 2.5 meter per second, and the diameter of the main pipe is also given 30 centimeters. What is the velocity in case of 15 centimeters dia pipe? Now what they have asked, what is the discharge flowing through the pipe and what is the velocity in the branch pipe? Two heads they have asked. So here first we are going to determine what is the discharge flowing through the main pipe. What is the standard formula? Q is equal to AV. That means area of this dia pipe into velocity flowing in this pipe. Okay, right. What is area? Area A is equal to pi d square by 4. That is equal to pi into what is the diameter? 30 centimeters. That converts into meters. That is 0.3 meters whole square divided by 4. This is equal to pi d square by 4. D is 30 centimeters, 0.3 meters whole square, pi 0.3 whole square divided by 4 is equal to area is equal to 0.07068 meter square. Now we have determined the cross-sectional area of the main pipe. And velocity of the main pipe they have given 2.5 meter per second. Therefore, discharge Q is equal to area, that is 0.07, not 3, 7068 into velocity 2.5 meter per second. Therefore, discharge Q is equal to 0.1767 meter cube per second. This is the first question. What is the discharge flowing through the main pipe equal to? We know one standard formula, discharge Q is equal to AV. Diameter given. From the diameter we have determined cross-sectional area, and velocity in the main pipe given, that is 2.5 meter per second. Area into cross-sectional area into velocity, we have the discharge flowing through the main pipe, that is equal to 0.1767 meter cube per second. And second question, what they have asked, what is the velocity at section, what is the velocity at 15 centimeters dia pipe. Now we are going to take right, this is the main pipe, this is the branch pipe, this is 15 centimeter dia pipe, this is 20 centimeter dia pipe. Okay, this is equal to D1, this is equal to D2, V2 is equal to what we are going to determine? V1 is equal to given, that is equal to 2 meter per second. So now we are going to determine the velocity in the 15 centimeter dia pipe. Now we are going to apply continuity equation. What is the continuity equation? A1 V1 equal to A2 V2. That means this is pipe 1 this is pipe 2. That is one more, but here continuity equation is not applicable. Why? Because this is not water flowing in one pipe, but this is branch of pipes, two branches divides into two branches. The main pipe is divides into two branches. So therefore we are going to determine the velocity at 2 is equal to, already we have determined Q here. A is also we know, and also velocity is also given in the main pipe. Now we are going to use the formula Q is equal to A1 V1 plus A2 V2, or Q is equal to Q1 plus Q2. That means the discharge from the main pipe is equal to discharge in the branch pipe 1 plus discharge in the branch pipe 2. Therefore, Q is equal to Q1 plus Q2. Q1 is nothing but A1 V1. Q2 is nothing but A2 V2. Yes, already we have determined the Q value. We know Q is equal to known to us. Area in the pipe 20 centimeter dia pipe, dia given, automatically we are going to determine the area, and velocity is also given, that is equal to 2 meter per second. A2 15 centimeters dia, pipe dia given 15 centimeters. From that 15 centimeters dia we are going to determine the area, and velocity is unknown. Right, what is Q? Q is already determined, that is equal to right, first we are going to determine the A1. A1 is equal to, what is the formula? Pi D1 square by 4. Pi into what is the D1? 20 centimeters, so that converts into meters, so divided by 4, you have the cross-sectional area of the pipe 1, that is equal to 0.0314 meter square. Then A2. A2 means that is the 15 centimeter dia pipe cross-sectional area. A2 is equal to same formula, pi d2 square by 4, that is equal to pi into what is the diameter? 15 centimeters, that converts into meters, 0.15 square divided by 4. You have the cross-sectional area of the 15 centimeter dia pipe is equal to 0.01767 meter square. Right? The A1 known to us, A2 known to us. Right? In this equation, discharge already we have determined. A1 is known to us, V1 is known to us, A2 is also known to us. Only unknown is velocity of the flow in case of 15 centimeters dia pipe. Right? What is the discharge Q? Q is equal to, already we have determined, 0.1767 meter cube per second is equal to, what is the A1? A1 is equal to 0.0314. 0.0314 into, what is the V1 velocity in the 20 centimeters dia pipe? 2 meters per second plus A2. A2 is determined here, that is 0.1767 into V2. Right? Only unknown is V2. Right? This is numerical value, this is numerical value, this is numerical value. Only unknown is V2. From this equation, V2 velocity in 15 centimeters dia pipe, V2 is equal to 6.44 meter per second. This is the velocity in the 15 centimeters dia pipe. In this problem, we have determined two values. One is the discharge flowing through the main pipe, Q, that is determined direct formula. Q is equal to AV. A is based on the diameter. We have determined the cross-sectional area. Velocity in the main pipe given. Discharge is clear. Then discharge of the main pipe plus discharge of the main pipe, Q is equal to Q1 plus Q2. Based on this equation, all parameters are known here. Only unknown is V2. V2 is equal to 6.44 meters per second. U2 is, that means V2 velocity in the 15 centimeters dia pipe is equal to 6.44 meters per second. Right? And one more problem, this is also same problem, but here this difference is earlier case, the pipe carrying water, but in this problem the pipe carries not water, pipe carries oil. The specific gravity of the oil is given. That is the different. Remaining entire same what we have solved the problem earlier, same steps. Here we are also going to follow the same steps, but the only earlier case the pipe carrying water, here pipe carrying oil. That's all. That is the difference. Right? Once you read the problem, what data they have given, what we are going to determine. Right? A 25 centimeters dia pipe carries oil. 25 centimeters dia pipe. 25 centimeters dia pipe. (25 centimeters dia pipe). 25 centimeters dia pipe carrying oil of specific gravity, of specific gravity equal to 0.9 at a velocity of 3 meters per second, and velocity is also given 3 meters per second. Right? Then at another section the diameter is 20 centimeters. So this is the another section. This is section 1-1. This is section 2-2. Or this is the another section. diameter equal to 20 centimeters. Find the velocity at this section. What is the velocity at 20 centimeters dia pipe, and mass rate of flow, and also mass rate of flow is equal to what? Right, in this problem, a pipe carrying oil of specific gravity 0.9 and diameter of the pipe is 25 centimeters. At 25 centimeters the velocity is also given. The pipe cross-sectional area gradually reduces at some point. At that point the diameter is equal to 20 centimeters. What is the velocity V2 at the 20 centimeter dia pipe, and also mass flow of oil? That two heads here they have asked. First, based on the given data, first we are going to determine the V2. Right? What is the formula? Apply here also continuity equation. A1 V1 is equal to A2 V2. Area, A1 means area at section 11, V1 means velocity at section 11, A2 means area at section 22, V2 means velocity at section 22. Right, what is area at section 11? A1 is equal to, A1 same formula, pi d1 square by 4, pi into what is the d? Diameter is equal to 25 centimeters, that converts into meters, so 2.5 meters divided by 4, this is equal to, what is the area? A1 is equal to 0.049 meter square. Then velocity V1 is given, that is 3 meter per second at this section 11, or at 25 centimeters dia pipe velocity is equal to 3 meter per second. Right, that is okay. And A2 means area, cross-sectional area at section 22 at a diameter 20 centimeters is, that here also same formula, pi d2 square by 4, that is equal to pi into, what is the d2? Diameter at section 22 is 20 centimeters, that converts into meters, so divided by 4, 0.2 square divided by 4 equal to, the area at section 22 is equal to 0.0314 meter square. This is area at 15 centimeters at 20 centimeter dia pipe. This is the area at 25 centimeters dia pipe. Now, area we have calculated based on the given diameter at section 11, velocity at section 11 given, area at section 22 or the diameter 20 centimeters dia, the area is determined, only unknown is V2. Right? Now, from this equation, V2 equal to A1 V1 divided by A2. What is A1? Already we have determined here. A1 is equal to 0.049 into velocity at section 11, that is equal to 3 meter per second, divided by A2 is equal to, already we have determined 0.0314. Therefore, velocity at section 22 is equal to 4.68 meter per second. This is the velocity. Right? Clear? This is the velocity at a 20 centimeter dia pipe. V2 is equal to 4.68 meter per second. Right? They have asked one more question. What is the mass rate of flow? Mass rate of flow of oil, that we are going to determine here. Right? Mass rate of flow of oil, mass rate of flow of oil. Right? We already, I have given mass of fluid or mass of any item equal to, we know one standard formula, mass equal to density of the standard liquid into volume or discharge, Right? Here, based on this problem, discharge, or this is also written as rho mass density into A1 into V1, or rho into A2 into V2. That means at 25 centimeters dia pipe discharge, or at 20 centimeter dia pipe discharge multiplied with the density, we have the mass. Mass equal to mass density into volume, or mass equal to mass density into discharge. Discharge is denoted by Q. Q is equal to A1 V1. Right? Now we are going, any problem at section 1 we are going to take the discharge, okay, or at section 2 this is the no, right, this is our section. This is large diameter, small diameter. This is 20 centimeter dia pipe. This is 25 centimeter dia pipe. Now we are going to discharge here or here, any one, there is no problem. Now we are going to take the discharge at section 1 Therefore mass is equal to rho into A1 V1. But what is rho? What is rho? If the pipe carrying liquid, if the pipe carrying water, the rho equal to 1000 kg per metric cube. That already I have given to you. Standard liquid or the water, the mass density is 1000 kg per metric cube. Mass density equal to 1000 kg per metric cube. But in this problem, the pipe carrying oil of specific gravity 0.9. Based on this specific gravity, we are going to determine the density of the oil. Right? Density of the water we know. Density of the oil, I have given one formula. Density of oil equal to specific gravity of oil into density of standard liquid. This formula I have given to you. Density of any liquid is equal to specific gravity of that liquid into density of the standard liquid. Right? Based on this formula, therefore density of oil, rho oil, is equal to specific gravity of the oil is equal to, that is given in our problem, 0.9 into density of the standard liquid. Density of the standard liquid is 1000 kg per metric cube. This is equal to 900 kg per metric cube. Right? The density of the oil, the density of the flowing fluid is 900 kg per metric cube. Are you clear? If water is flowing through the pipe, density of the water is equal to 1000 kg per metric cube. There is no problem. We have direct value. But the density of the oil is determined by using this formula, 900 kg per metric cube. Right? Density is very clear. The density is equal to 900 kg per metric cube. A1 already we have determined, that is 0.049 into velocity. Velocity at section 1 that is at 25 centimeter dia is given, that is equal to 3 meter per second. Finally, mass rate of flow is equal to 132.23 kg per second. This is the mass rate of flow. Right? In this problem, we have determined the velocity at section 2 to V2, and also mass rate of flow or mass of oil per second is determined, that is equal to 132.23 kg per second. Right? Thank you. These are the problems related to continuity equation.